All right, good evening, everyone. Today we are going to be deriving the natural base E, which is commonly referred to as Euler's number. And Euler's number is a constant. It's an irrational number, very similar to pi. So suppose that we have $1 that is deposited into an account that pays 100% annual interest. How much money is in the account after 1 year if the interest is compounded annually, semi-annually, quarterly, monthly, etc. So if we are compounding something annually, we only do it one time a year. Semi-annually means half. So within half a year, so there's 2 halves in the year. So therefore we compound it twice a year. Quarterly means that there are 4 parts. Monthly means that there are 12 months in a year. And daily is 365 days. So we'll go up to here. We can actually go as n goes to infinity. That's what happens, and we'll see what happens. So you have $1. We have $1. So we're gaining interest, so we add more money. So 100% of $1 is 1. So at the end of the year, we would have $2, right? However, let's say we compound it semi-annually. So we take the 100% and we cut it in half. So we take 100%, cut it in half, that's 50%. 50% as a fraction is just really just 1/2, right? So what we can do is, well, you know what? After 6 months, we take $1, we add 1/2 of the 100% interest, which is, well, 1/2 of 1 is 1/2, which is also known as 50 cents, right? So after 6 months, we have $1.50, but we take that $1.50 and we compound interest on that as well. So at the end of another 6 months, so at the end of the year, we compound another 50%. So now this will become $1.50 after 6 months. Then we compound another 50% interest. So $1.50 times $1.50 will give us $2.25. So you're actually accruing more interest, right? Because you're accruing, essentially this is why it works like this. You're accruing interest upon interest. And in the real world, most bank accounts, they compound your interest daily. However, they pay you the money after at the end of each month. So it's not very similar to these examples here. However, in this example, you're accruing interest after the 6 months. So that's why we have an additional 25 more cents. So let's say you do it quarterly, right? So 100% you divide it by 4. 100% divided by 4. So this is kind of weirdish. Instead of writing 100%, we can just write 100% as a decimal. So 100% as a decimal is really just, it's 1/4, right? So instead of writing it as a percentage, we can write 100% as 1.0, which is really just 1 divided by 4. So after 3 months, right, because a quarter of 12 months, because there are 12 months in a year, you have $1.25. And I'll keep it as a fraction. You have $1.25. After another 3 months, you multiply this by 1.25, so 1.25. Then after another 3 months, you multiply by 1 times, you multiply the factor by 1 plus 1/4. Then at the end of the year, you multiply it again because you do this 4 times. So as you notice, what you're doing is you're doing 1 plus 1/4 raised to the 4th power. And this will get you so if you did it 4 times, you would get $2.44. So if you notice that this pattern, it goes like this. it goes like 1 plus 1 over n, where n is the number of times that you compounded, raised to the power of n, right? If this is within a year. So if we did it monthly, then it would be 1 plus 1/12, and you multiply it by itself 12 times, it is just 1 plus 1/12 raised to the power of 12. And this is beforehand. So if you did it monthly, you would get $2.61 because you would round it to the nearest hundredth. So $2.61. Right? If you did it daily, if we compound it daily, then it'll be 1 plus 100, 1 plus 1 over 365, raised to the power of 365, and that will give us approximately 2.71. Right? So essentially, what happens if we decided to compound something hourly? There are 8,760 hours within a year. What happens if we did it minutely, if that's even a word? There are 525,600 minutes. What happens is it is approaching a number, and that number is what we represent as E. It's about 2.1828 ... So essentially, as you increase the number of times that you compound something, right, as n goes to infinity, of 1 plus 1 over n raised to the power of n, you get this magical number E. So this is one of the proofs for E, or of how you derive it. So if you go to our next page here, so E is equal to this particular value, 1 plus 1 over n raised to the power of n, as n goes to infinity. So if you can take a look at what happens when n is 10, when n is 100, etc., it's get larger and larger and larger. And so E is approximately 2.72. So E is approximately 2.72.